Okay, hi there, my name's Max Wolf. I'm a TA for CS61A in spring 2015. We're looking at a slightly harder tree problem from discussion 4. This problem is asking us to find a path given a tree in some value from the root of the tree to some element in the tree if that element is equal to the value. Otherwise, we want to return none. So read the problem and give it a shot, and then come back and take a look at the solution. Okay, so let's find path. We take an argument tree, and we're looking for some value. So the first thing I like to do when I think about these tree problems is I like to draw some sample tree, and then think about what my base cases are. So trees, we almost always solve them with recursion because they have this really nice property where each of their branches are also trees. And when I think about base cases for trees, I tend to think of sort of two really easy base cases. So base case number one that always jumps to mind is the tree a leaf? If it's a leaf, then we must have gotten to the end of our tree. We can't call a tree function on any of our branches because there are no branches. So is leaf tends to be sort of one of the base cases I think of. The other one is, can we get some silly, if we have a second input, can we get some sort of silly input that we know is just going to be that we're able to return really quickly? So sort of easy input, right? We just know the answer just from looking at the root. All right, so let's think about sort of those two examples, right? So say I'm given a tree with no children, so a leaf. So one base case is I'm given something like I'm asked to call, I say find path, this is T1, with T1, and I'm asked to find something that's not in the tree. So if I know it's a leaf, and the value is not equal to, the root is not equal to the value that I'm passed in, then I can automatically return none. So this is one sort of one way to think about our base case. And what's another base case we could be given? Well, this actually sort of applies for everything, not just leaves. But say I'm passed in T1, and I passed in something that has the correct value at the root. But if this case, I can just return true right away and return the path. In this case, the path is just going to be, a single item list with the value 2. Okay, so let's write those base cases out. First base case is, we sort of think about the successful base case first. If root of tree is equal to x, then what I want to return root of tree, root of tree, but in a list. So I'm expecting a list as output. So let's think about, okay, so this is going to be tackle our sort of, we already have the answer because it's at the root. Now the second thing we can think of is if is leaf. This is actually not in the solutions, but I think it's a decent way to think about sort of attacking normal tree problems. So I always try to think about the sort of the is leaf case. So our other is leaf, so other cases is leaf tree, and, well, it must not be a root, right? The root must not be equal to x, so we would have already hit this base case. So I can just say if is leaf tree, then I want to return none. And so now we know at the very least that once we get to a leaf, we're going to return none. And if we call this find path on all of our branches, we're going to get one of these two outputs, right? We're going to get none or we're going to get some list. Okay, so now let's think about sort of our other case. So else. This else is actually optional. You'll see that since I'm returning in both my if statements, I don't need this else, but I'll put it in here anyway. Okay, so otherwise, what I want to do is since I know that so now we can sort of think about this graphically as well. I know that I'm not at a root, right? So I must have a list of branches, which are subtrees to look at. Let's think of 3, 4, 5. So any path that I create that's coming from this list of branches, I need to check any path that I create that includes this list of branches. So say I'm looking for the element 3 and it happens to be in here. is going to include my root 2 as the first element of whatever path I return. So if I'm able to find a path, then what I want to do is I want to do 2 plus sort of the path that I get from one of my branches. Path from branch. Right? So now we sort of have an idea of how we want to approach this problem. We're going to call find path for each of my branches. If it returns a path, then I'll return a list of the first element in my big tree concatenated with whatever path I return. Okay, so now first let's pull out my branches. I know that they're a list of trees, so we'll sort of save them in a list. Branches of tree. This will just help us remember that they're a list of trees. And now for every path that I can get for path in, let's create a list of paths, of potential paths. So for path in, find path, branch. So we'll find path for branch. We're still looking for the same value that we were looking for before. For find path branch, X for branch in trees. Great, so now I'm going to pull out the path from this list of paths that I've generated using a list comprehension. Now, if the path is none, then it's going to be a false value. If the path has a list, it's going to be a true value. So this if path is going to say, okay, if I've found a path, then what I want to do is I want to return, well, exactly what we talked about right here, right? We want to return my root value, root of tree, plus, in a list, plus whatever the path that I got out was. Okay, great. So this is actually going to be the solution, and then if we want to sort of be formal about it, we can add a return none. Although we don't need this because Python is going to automatically, once it gets to the end of a method, return none, so we'll erase that. But now we know that if we find a path, then we're going to just return sort of the root plus whatever the path is. So let's think about this in sort of an example. So if I call find path on this T1, and I want to look for 5, then what's going to happen is I'm going to call find path on this big tree. This big tree, we're going to check each of our cases. The root is not equal to x, so we don't execute this. It's not a leaf. And so we can extract each of our branches, and now we're going to call find path on each of our subtrees. Right? So now we want to look in each of our subtrees to see if there exists a path to 5. Let's check our first subtree. Our first subtree does not have 5 as its root and is a leaf, so we'll return none from here. This one we're going to have the same problem, we'll return none. Now this root right here is 5, and so we're going to return a list that's equal to 5. So now each of our paths is going to be a list of none, none, and 5, and the list 5. So now we're going to do for path in this list, none, none, list 5. The first value is none, so if path is going to be false. Second value is none if path is going to be false. The third value is equal to the list of 5, so we're going to return 2 plus list 5 is equal to 2, 5, which is exactly what we want. Okay, great. So if you have any questions about this, feel free to post a comment on YouTube or in Piazza, and I'll try and answer it. Thanks for watching.